Okay, so we have a monomial times a binomial. Does everybody see that? I'm trying to get you to practice your vocabulary here a little bit. So what's the monomial in this multiplication? The 3a. What's the binomial? A squared minus 4a. Binomial means it has two terms. Do you see the two terms? What are the two terms of a squared minus 4a? A squared and not 4a, but negative 4a. Okay, those are the two terms. You can think of a squared minus 4a as a squared plus a negative 4a, right? We don't write it that way, but when you do, it helps you see the terms. The terms are, when you write them this way without minus signs, the terms are between the plus signs. So there's a term, a squared, and then the whole thing, negative 4a is another term. Okay? So when you go to do the 5.1 homework, that idea can help you out to identify the terms or monomials that make up the polynomial. So it's a binomial because it has two terms. All right, anyway, you don't need to necessarily think about that to do this problem. What law do you think about to do this problem? It begins with a D, distribution. So we're going to distribute 3a, and distribution works when there's a minus or a plus involved, right? Notice what we didn't do in the first one. There's no distribution going on here because the operation between the two monomials is multiplication. You're not going to distribute the negative 2x cubed to the 4 and to the x. You're not going to multiply twice here. A lot of students make that mistake on more complicated looking multiplications. Distribution only comes into play if you have a minus, if you're multiplying by something on the outside and you have a minus or plus in between terms. In other words, if you have more than one term. Okay. So we're distributing over subtraction. So here's a step you don't need to show, but it may be helpful. You're going to get 3a times a squared when you distribute to a squared. Would you buy that? And then minus, put the minus out in front, distribution over subtraction. Then what's the other multiplication going to be? The thing you're distributing, 3a times 4a. So again, I show this step, not because I'm going to show this step every time, but to remind you what's going on here, the distribution property. That's what we're using. Distribution over subtraction. Now, you could skip this step entirely and just do the multiplication in your head once you get comfortable with this. What's 3a times a squared? Do you see where we're using the first law of exponents here? 3a times a squared, what's that? It's implied that there's an exponent of 1, so you have like bases. A to the 1 times a squared, you keep the base. The 3's not going anywhere. Keep the base on the a and add the exponents together. 3a cubed for the first term. That minus is still there. And then the second term, now I'm not going to reorder the multiplication every time, but remember, you could think of this as 3 times 4 times a, right? Just by switching it, instead of a times 4 in the middle, you have 4 times a. So 3 times 4 times a, what's that going to be? So 12a squared? Yeah. In this one, we have two what multiplied together? Two polynomials, but be specific. Two binomials multiplied together, right? Now, when you multiply two polynomials, in general, all you have to remember is to distribute every term in the first polynomial times every term in the second polynomial. Distribute every term in the first to every term in the second. So let's do that, and then I'll remind you of some of you are thinking FOIL, yeah? I'll remind you of what that says in a second. But the FOIL only works on multiplying binomials. The technique I'm about to show you works on any polynomial. So I have to distribute the 3r. I just start from left to right. Well, with the left-hand term in the left-hand binomial. 3r is the left-hand term. I need to distribute that to every term in that second binomial there. And I don't want to forget the operation in between after I multiply. So what do I get? 3r times 2r? What is that going to turn out to be? 6r squared. Everybody comfortable with that? Okay. Now I'm going to distribute 3r over a plus 1. So what's the operation? It stays plus, and what's 3r times 1? 3r. So now I've exhausted everything that I can multiply this 3r by. So I move on to the minus 4. And I think I'm distributing the minus 4. So if I do that, what do I get when I multiply minus 4 times 2r? Or really, it's 2r distributed to over a minus 4. What's the operation? Minus, right? And then 4 times 8, thinking ahead there, 4 times 2r? So, well, we already had the minus, so 8r. Okay? And now we're going to distribute the minus 4 over the plus 1. What do we get? Minus 4 on the end. You have to include the operation. It's either going to be plus or minus. Okay? All right, do you see any like terms? 3r minus 8r. Minus or plus? So 6r squared minus 5r minus 4. Tomorrow, we'll go the other way around. We'll go backwards and factor using the reverse method as to what we just used. So keep that in mind. Okay, FOIL, it's an acronym. What does it stand for? First. I say outer. Some people say outside. Same difference. Inner or inside, and last. So we're referring to what terms we multiply from the binomial. So the first terms would be the 3r and the 2r. And it's just a reminder, right? You don't need this acronym. In fact, it only works on binomials. But it's nice for binomials. It is nice. So the first terms, you multiply the 3r times the 2r. Oh, and you'd get exactly what we got, 6r squared, right? The outer is referring to which two guys? The outer is referring to which two? Yeah, the outside term on the first polynomial would be 3r, but the outside term on the second polynomial would be 1, right? And so 3r distributed over a 1. Oh, yeah, you get 3r, yeah. So we were doing FOIL and we didn't even know it. The inside terms, what would those be? -4 and 2r. So, and you multiply those together, you get the minus 8r. That would be the inside or inner terms multiplied together. And then what would be the last terms? -4 and 1. -4 and 1, which is minus 4 times, or minus 4 distributed over plus 1 makes -4. So we did FOIL and we didn't even know it. But any order of multiplication really works. Doesn't matter if you go the outer or the inner is multiplied together first.